So my plan for this is to put the wall connector right there on the pillar in between the two garage doors. I'm going to be parking on that side of the garage. So panels here feed the cable up the wall to the attic, run it diagonally across and down here, which I'm going to put inside of a conduit. I can't do it behind the wall because that's solid 2x4, that pillar. So I'm going to put a conduit, run a conduit right there to midway down and feed the cable down inside that. So as far as supplies go, the biggest hang up that I had was figuring out, what's the right cable to use and what's the right breaker to use. It calls for a 60 amp breaker and 6 gauge wire if you're just doing a single car. In my case, Model 3. But there's THHN wire, and then there's just Romex. And after doing some research on it, determined that this wire would be just fine. So you've got 6 gauge. The 6/3, the 3 represents the number of connectors inside. So there's three connectors, 2 hots, a neutral, and then plus a ground wire inside there. And this is fine for inside use. And the breaker is a 60 amp breaker. You want to just make sure that it obviously that's the correct breaker for your panel. So what I did was reference the numbers that are on here, and did a search for that and found a 60 amp breaker. Biggest challenge that I had was figuring out how best to fish that line from the panel up into the attic. In my particular case, just above the ceiling tile there, my roof slopes down, so it's extremely cramped in the attic just above that header. I got some fish tape, and I was just going to fish a line down and try to find the hole, if you will, on that on the breaker box, but just decided this wasn't worth the hassle, so I went ahead and cut out this piece. So when I climb up in the attic and fish that cable down, I'll just get it down to this general area, and then I'll punch out one of the holes here and drop it the rest of the way down. I've got a 200 amp panel. Initially, this 60 amp breaker here, these 2 black lines coming off the 60 amp breaker in my case, feed over to this other panel, and those 2 lines, and they feed this sub panel. Initially, this was all full, but I didn't want to put a 60 amp on this sub panel, being that there was only 60 amps worth of service that was supplied to it. So I took some of the 15 amp breakers that were right here and moved them to right there to free up that space. So I'm going to climb up on the attic, and drop down that line to here, grab it, feed it through to here, attach the breaker, connect it in here. Obviously, I'm going to shut down the power before doing any of that stuff. Okay, so that was what I hope to be the hardest part of this. Essentially what I did was, and you can see the cable here that came down. Essentially what I did was I measured the distance from the top of the panel here, or from the top of the panel to the top of the wall. It came out to be 61 inches. So I measured the cable, 61 inches of cable, and put a piece of yellow tape around that, so I knew as I was feeding this down the wall, I knew at least how far I had to get it down. But ultimately, you just want to keep stuffing until you're confident that it's as far down as you can. In my case, I kept stuffing until I couldn't get it to go anymore. So now cable's through, so I'll get one of these brackets and feed it down through this hole, and then connect it into the breaker. So here's this connector that you want to use. I guess it's called an NM cable connector. This is what it looks like so. This is what you'll use here. It's essentially this thing, which protects it, holds it in place. Slap that on there, feed the cable up through it, and drop it down in there. Okay, so once you run the cable through the box, make sure to cinch these two down real well. Then pull your cable all the way down through, and then take that plastic, the black plastic outer jacket, just take a box cutter and gently slice that all the way down. Unravel all these wires. You'll have your two hot lines, your ground, which is this guy, and your neutral, which is this guy, which you really don't need. I'm going to go ahead and wire it up and then cap it off at that end, just in case I want to do something else with it in the future, which I doubt, but it's there, so I may as well use it. So the next thing is to attach these to the breakers, and then this one to the neutral bus here, and then this one to the ground bus. So once you have all these trimmed down to size, you'll have your ground here, which I'm going to tie into the ground bus, which is where all you see those bare copper wires in there connecting to the top part of that bus. And then the neutral here is going to go into the bottom part of that bus bar right there. Your two hots, you're going to connect into your breaker. And the next thing is just get them all connected. Okay, so got everything wired up, connected. Very simply, you've got your 60 amp breaker. You've got your two powers here. This neutral attached back here to the back of the bus bar in the back, the neutral. And then just above that, at the very top back here is our ground. And that ground is the important one, and they can go anywhere on the ground bar, on the ground bus bar that you've got space for. Make sure to leave this breaker off until you're finished wiring up the wall connector. And that's it for the panel. We'll put the covers back on, and then we'll put the sheetrock back on that, and put some spackling in there, paint it, and that ought to do it. Again, just to reiterate, if you're not comfortable with electricity, don't mess with this. Obviously, make sure to turn that main breaker to the house off, and just understand that these two black lines coming in are coming in from the street, and they're hot. So even when you turn that off, you shut down all the power and everything below, but it's still hot right there. So obviously be very mindful of that and very careful, because that will kill you. Yeah, this is just for my particular application. I wanted to put it in between the two garage doors. So I measured where the hole would be at the top, used a long drill bit, went straight up and right out through the roof. So I'm going to run a conduit through this, and should be ready to hook up the wall charger at that point. There's that header that we drilled through, and now it meets up with the roof. And there's the hole in the garage, and the hole right through the roof deck. Gonna have to fix that. So just to give you a bird's eye view of my attic, and obviously this will be different for everybody, but my breaker panel is the top of the wall where the breaker panel is back there. And you can see the cable snakes across here. So this is my challenge for this one, is this header beam is right above the ceiling in between the two garage doors. So that point right there is right where I drilled up. And again, you can see where I drilled up at a really long drill bit and came up and went right through the roof. I had to go back with a reciprocating saw and cut that notch out, which took a couple hours to do to get that hole to where I could feed that cable through it. That was tough. The hardware that I got for this was a 5-foot conduit. Ideally, it would have been 1 inch because this connector, which is a 1 inch diameter here that's threaded, will go into the top of the wall charger, into that back plate. And again, that's a 1 inch threaded connection, but all they had was a 3/4 inch conduit. So that's not going to be a big deal. I'll slide this on the end of it, tighten that down, and there'll be a little bit of play here, but it won't amount to anything. It won't be a big deal. Outside of that, 3/4 inch EMT brackets to hold this conduit against the wall, and screws. And that's it. Okay, so my Tesla Model 3 arrived yesterday. I went and picked it up. Kind of a funny story. I had ordered my wall charger, my wall connector, about 2.5 weeks ago, and it had yet to come in. So my Tesla got here before my wall charger did. So on the way home from picking my car up, swung into Home Depot and got the necessary pieces to install the Nema 1450 connector, so I could charge it and use that until my wall connector came in. Well, when I got home, my wall connector was sitting on the front porch, so it arrived that same day, just when I got home. So what I've done here is cut the cable. And I'm going to go ahead and install that Nema 1450 connector just to show you how it's done. And then I'll take it, disassemble it, and hook the wall connector up. Okay, so what we'll go through first is how to connect the Nema 1450 connector. Whether you go with a wall charger or the Nema 1450, the only difference is really the connector itself, which is the Nema 1450. It looks just like this. And then whatever you drop it into. Now I've got a box here, so I'll slide that line down through that 3/4 inch EMT pipe, and then run that pipe all the way into this box. I'll cut a hole in the top here, drop it down into that, so the wires come out into that, and then I'll strip the red, black, and green, just like we did at the other side of the breaker box, and attach those into the back of this guy. Pretty self-explanatory. You've got the Y here, you've got the X there, that's for the green or the black, it doesn't matter which. You've got the green, which could also be just the bare copper wire, that's the ground. And then you've got the white, which is your neutral. So you just you'll thread the wires down, strip them down just like we did over at the breaker box, stick it in here, tighten that screw down on top of it, and obviously those wires will be coming out of the top of that. Connect them here. This will go on top of that guy like so, and then you'll take your face plate, which is this guy. Take your face plate, drop it right over the top. Mount that to the wall, you're good to go. These pieces here, 16 bucks. That's what it'll cost you. The wall connector is 500 bucks. It's a cool thing, looks neat on the wall, but it charges at the same amperage as this Nema connector. So I'll hook all that up and then I'll be back. Okay, so here's the wire inside the pipe, and you got your your red, black, white, and that bare copper wire, or it could be green, is your ground. And again, the white, or the Y and the X, it's going to be your red or black, doesn't matter which. Your white's going to be your neutral. Your green is going to be your ground. So I'll get this wired up. Okay, so here's the connection so far with the Nema 1450. Again, the application here will vary greatly depending on how you do it. In my case, I decided to run it down from the top of the wall on the outside. You may decide to go inside the wall and then come out through the back of the wall, in which case there's a knockout in the back of this blue box that you would just punch that knockout out, run the wire through the back of it, and then connect it like I talked about a minute ago. And then you got the 4 screws there to mount the receptacle to the blue box. The key thing about the receptacle is that you want it orientated just like this, with a little circle deal at the top here and then the bottom 3 at the bottom, even though the writing on the receptacle is going to be upside down. This will ensure that when you do plug the cable in, the cable is hanging down as opposed to going up and then looping back down. So that's how you want to do that. Okay, so we're all done. This is what the final product looked like. This is why you want the receptacle oriented the way that I was showing you, so that the cable drops down and doesn't go up and you'll have to loop it back around. You want to put one of these brackets to hold your bar in place if that's the way you go. And the last step for this, flip the breaker on and hope you get green lights on the charger. So looking good. And that's what you'll see. And then we'll plug them in and see what we got. So to do that, open this thing up, you push down that little dot, plug him on in, and that should blink green. Very nice. So that's how you install that guy. Oh, and the last step, you want to make sure that you're getting 32 amps of charge. There you go. 32 amps. Good tune. Okay, so to be sure, what I've got here is the reducing bushing and the compression connector. Here's the packaging for both of those. I happen to have some Teflon tape sitting around, so I went ahead and wrapped that around the threads just for fun. This is not going to be in any kind of environment where there's going to be any kind of moisture, or at least there better not be. I've cut down my pipe here to fit the distance that I marked, and this piece will slide down on the pipe, and I'll tighten that piece that just fell, and then the reducer will go just like so to take it from 1 inch down to 3/4. When you get done with that part of it, you'll have your conduit feeding into your compression connector. Cinch that down nice and tight, and then that's going to sit into that reducer, which you're going to screw into this wall plate and get everything nice and snug, but obviously not over snug. It looks good. It's to code. It's a good way to do it if you're going to use this top connector. The next step will be mounting it to the wall. What I'll do is come up here, probably pull some more of this jacketing off to free up these wires. I'll feed the conduit up along this wire. So these wires are sticking out through through this bracket, and I've got enough of the wire coming out of it to play with. Okay, so at the end of the day, what you got is this. So this conduit is extremely sturdy, no movement at all. I went ahead and put 4 screws, 1, 2, 3 in the back, 4 back there. I went ahead and mounted 4 screws. I'm going in a 2x4, so I just use plain old wood screws and threw some washers in there for good measure. Black to the L1, red to the L2, ground to the ground. This neutral is not used with the wall connector. It is used with that Nema connection, but it's not used here in the with the wall connector, so I'll get a wire nut and cap that off. And then we will install the wall connector on top of this and run these cables into the back of it. Now, again, all this depends on your application. Here's the low profile wall connector. If you were coming in, if this was hollow behind this, I would have dropped the cable down behind the wall, drilled a hole, brought the cable out through the wall, mounted this wall plate here with the cable coming out here instead. But these spaces in between the garage doors are solid 2x4, so this made a whole lot more sense for my application. If you do use the low profile rig, it's going to slap onto the back of this just like so, and your cable's going to go right through here. So this is threaded as well, so you want to make sure that you use the right connector to run that to cable through, ideally. When I put the when I mount, let me get this out of the way. When I mount the wall connector onto that top bracket plate here, those cables that are hanging out right there, I'm going to fish those right through this hole. It's going to come out there, and I'll put one of the plugs in here to cap this hole and to cap that hole, because you want to keep these holes capped. So that's the next step. Okay, so the next step is we need to take this outer cover off. We're going to use these Torx bits. Pop that screw off, then very carefully take this outer cover off, and then below that there's going to be 6 more screws that will use the other Torx bit to unscrew, and that'll take the other cover off and expose the inside of it. So that's what we'll do next. Okay, so once you get that outer cover and the inner cover off, this is what you'll be left with. If you're using the top mounted bracket, those wires there will be fed through the back of the connector, through that hole right down there. And just to reiterate, you can see on the neutral, you got a wire nut on that, as that, again, that neutral is not going to be used for the wall connector. That's only used for the Nema connection. Okay, so we've got this guy mounted. Everything's looking good. You've got your 3 wires that are coming in from the back of the top mount bracket, like so. Those guys are going to get connected. Your black is going to go into this guy. That's the L1. Your red is going to go into this guy. That's the L2. Your ground is going to go into this guy in the back here, right there. So I'll get those connected next. Oh, one other note here about I'm going to point out is is you see this little silicone bead around here, this gasket. When you take that middle plate off, make sure that this doesn't get disrupted. When you put that inner plate back on, you want to make sure that you've got a good seal there. That's what keeps any water and moisture out of that as well. All right, so that is done. For me, this is pretty difficult to get these two in correctly. You want to make sure to back these screws out, not all the way, but until they're a little bit loose or wobbly inside that housing. And when you look at these, you'll notice that they're rectangular in shape. And if I zoom in on the ground wire at the bottom, you can kind of see how it's going in there long ways, or sideways, if you will. This is the wider surface. If you were to turn this 90 degrees, it's a shorter surface. So if you stick it in there where it's longer sideways, I believe that's what needs to be done here with these guys, and that'll allow you to cinch down on those two nuts to tighten those guys in. But for me, it took some doing, but you'll get it there. Okay, then the last step is to take this tape off. That exposes this guy here. That is going to attach into this guy, and then we will use the screws here to mount that plate again. Yep, so just one more thing before we put that cover on is we want to get these settings dialed in. I think in most locations you're going to have the line to line is going to be 240 or less. So you want that number one jumper to be down and the number two jumper to be up, which is how it comes from the factory. It's a little difficult to tell, but the number one is down, the number two is up. And then secondly, on that dial right there, you're going to turn that to where it points at the number 9, and that corresponds to this table here. We used a 60 amp breaker, which provides a maximum output current of 48 amps. So we're going to turn that dial to a number 9. And then you can see you got the dial pointing to number 9, the number 1 jumper down, the number 2 jumper up. Okay, so that's done. You just take the inner cover and place it back on there. Obviously, again, make sure not to disrupt the gasket. Get your screws down there, make sure you don't over tighten them. I think I went to number 4 on my choke, my drill. And then the outer cover snaps into place. You want to start with getting that into position, then work your way up. Make sure you get snaps all the way down. Now it's time for the moment of truth. So we will hit the breaker, see what the lights do. So I believe you see that orange light first, and then if it starts that green wave, or the green light rather, I think the wave is just when you're charged it, and we're looking good. So last step, or not last step, but a couple housekeeping things. So you want to plug that hole, and we're going to use that one to do it, and then we'll take these 4 side pieces to plug in. You got the one up top here, and then the one here at the bottom, and then the ones on the other side. So we'll do that next. So everything's hooked up, and that's the final product. There's our conduit coming down. I went ahead and bought one of these. I think they call it an organizer. This one's a top fit because just of my configuration, putting it in between the garage doors. This was not going to fit here, and I didn't want it sticking out, impeding the entry on the garage door. So I bought this rig, which has got a pass-through hole in the back here so the cable can come down. It's a little wonky in that it gets in the way of those garage door sensors. I may move those around a little bit, or I may try this for a little while here, or I may move this up here, or some variation thereof. But this was the reason I got the wall charger with the 8.5 foot cables. I didn't want a lot of cumbersome extra cable to contend with. Leftover pieces. It's not bad. I got this guy should have gone in to cover the hole that the cable would have come through had I done the rear entry or below entry. But I forgot to put that in, and I'm not going to worry about it. And this guy, I don't know where that went. I'm not going to worry about that either. So you should get blinking green Tesla here. And the wave on the wall. And this should spin up and show us 48 amps speed. So 243 volts, 48 amps, 33 miles per hour. And current charge at 48 amps too. And that's what you ought to see. So just a correction here, the wall charger has the potential to go up to 44 miles per hour on the Model 3 at 48 amps. And just an important note here, this is the table that's published by Tesla. You notice that the row, the 60 amp breaker is the maximum that is of maximum benefit. You can go with a bigger breaker, but it's not going to deliver you any more speed in charging. The Model 3 is going to top out at 44 miles per hour, the Model S 34, and the Model X 30. The benefit of going with a larger breaker, like a 100 amp breaker, would be if you're charging more than one Tesla. But as far as for single use, 60 amp breaker is as much as you need. And just as a point of comparison, at least for the Model 3, you can see the numbers there. It's 44, 34, and 30 for the Model 3, S, and X, respectively. If you look at the stats on the Nema 1450, it's 30, 23, and 20 for the Model 3, S, and X. So you get and also you can see there's a maximum output of 32 amps, which is why that is. But with a wall charger, you get a bit faster charging speeds. Okay, so it's been 3 days and it's bugging me, so I went ahead and opened it back up and installed that plug way in the back there behind the yellow cord. That's where that one goes to seal in the rear entry hole. This bottom conduit gasket is not needed in my case because I've got that plug in there, and you can see it, and then there's a gasket, so it wasn't needed. So that's it. It's actually been 2 years now since I've installed this thing. I'm just now coming around to put this video together. This is the first and only video I think I've made. Back there is where I've got my panel, and this has been working great. You know, I recommend assessing to see what kind of length you're going to need in your cable, and don't get the long cable if you don't need it. It just adds more bulk to it. But this setup has worked, has been working great. So hope that helps. If so, give it a thumbs up. I think is the right thing. All right. Good luck. It's fun. It's a good project. Good luck.